Greetings all, welcome back to learning. Today we're going to start with solving linear trig equations. This is where we left off before the March break, and gonna get started. So solving trig equations means that we are solving equations that will have the variables expressed in trigonometric form, meaning that the variables, this time we're going to see them in the form such as, say for example, sine of x, or cosine of x, or tan x, or cosecant x, or secant x, or cotan x, or some other variations of these forms. Now we're going to start solving linear trig equations. So we're going to start with linear trig equations, meaning that when we solve trig equations, so far we're going to solve equations that where sine, cos, tan, or all these ratios will be to raised to the power of 1. Okay, so sorry about this. So 1 second. So all these linear, meaning that they're all going to be to the power of 1. So you won't see a power or an exponent there. Okay, so let's get started with our first example. So in our first example, we have sine x cos pi over 6 minus cos x sine pi over 6 equals 1/2. So normally when we are solving equations, what we want to see is a variable, and I just spotted one here. So we have sine of x, that's one of the variables. Cos pi over 6 is just a number, okay? So cosine of x, oh, that's another variable right here. And sine pi over 6 is just a number, so that equals 1/2. Normally or ideally we want to have one variable throughout the equation, but in this case we don't. And we all know that solving equations is about simplifying the equation, condensing it to the shortest form possible, and that's what we want to do right now. So obviously sine x and cos x are not like terms, so there is no way of combining them. But if we take a closer look at the left side of this equation, you probably see that there is some familiar pattern in here that we notice. So in case we don't recall it, so here we go. This is the compound angle formula, and I'm going to write this on the side. So it's 1 second. So sine A cos B minus cos A sine B. So we're going to practice quite a few of those, so it's going to be easy for you to spot them from now on. And this would equal sine of A minus B. So applying the formula into this equation suggests that we rewrite the equation now as sine of x minus pi over 6 equals 1/2. So our unknown now is hiding right here. Okay, we're solving for angle x minus pi over 6 first, and again we have x minus pi over 6 now equals inverse sine 1/2. Now you probably recognize this ratio as one of the special ratios, so I'm going to quickly draw the two special triangles, and whenever I actually solve equations, I draw them on the side of my worksheet just so that I have them handy there. And here is one special triangle. You probably recognize pi over 4, and pi over 2. And the next special triangle, another right angle triangle, okay, perfect one. And here we get the measurements. So here's pi over 2, obviously right here, and we have pi over 4, pi over 4, and this is triangle. In this triangle here we have the angle 90, or pi over 2, pi over 3, and pi over 6. So the measurements are 1, 1, root of 2, and 1, 2, and root of 3. So the sine ratio of 1 over 2 is for the angle pi over 6. So getting back here, I'm going to say x minus pi over 6 must equal pi over 6 then. Now we all know that in a domain from 0 to 2 pi, we might have more than one angle that has the same ratio. Taking another look at our diagram here, I'm going to draw first the angle that I just found. And I'm going to try to draw a perfect line here. See if I can do it. Yeah, not bad. And we're going to draw the second angle that shares the same sine ratio. You remember that for the second angle, since it is sine, we reflect the terminal arm around the y-axis. That's because we want to maintain the value of y the same. And here we go. All right, and we are going to show where our angles are right here. So this is one solution and this is the second solution. And here, this is going to be one answer, and this is the second answer. And the two angles are pi over 6 and it's kind of easy to calculate the second angle. So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, and then 5 pi over 6. So we're going to say that x minus pi over 6 equals pi over 6, or x minus pi over 6 equals 5 pi over 6. Not done yet. We have to solve for x. So we have x equals pi over 6 plus pi over 6, or x equals 5 pi over 6 plus pi over 6. So here we have x equals 2 pi over 6, or pi over 3, or 6 pi over 6, or pi. Okay, so cheating here a little bit. Here, right. All right, so very excited that I found my answers. This is actually the end of the solution here. And I got two angles in exact form. Two solutions. Okay, so moving on to the next example. What we have in here is something very similar to the previous example. So again, if you would like to, you can pause the video and start trying this on your own. I will continue with the solution, obviously. And what we have in here is cos x, cos pi over 4 minus sine x, sine pi over 4 equals 1. So you probably recognized here the formula for a compound angle. And the formula we have here is cos A, cos B, minus sine A, sine B. All right, and we know this would equal the cosine of A plus B. Right? Remember, for cosine, when you had a difference, then you had a plus in here. So let's get started. So I will rewrite the left side in a condensed form. So that would be cosine of x plus pi over 4 equals 1. That means x plus pi over 4 equals inverse cos 1. So x plus pi over 4 equals, now think about what angles have a cosine ratio of 1. And I would say that we have the angle 0 as cosine of 1, and we also have the angle 2 pi with a cosine of 1. So we're going to say x plus pi over 4 is either 0 or 2 pi. So for x equals negative pi over 4, or x equals 2 pi minus pi over 4, or 8 pi over 4 minus pi over 4, which is 7 pi over 4. So let's take a look at our answers again. Remember that our domain is between 0 and 2 pi. Okay, we want to check and see if our solutions fit into the domain, into the given domain. And let me take a look at the first one. So we're going to say x minus pi over 4. It's not in our domain here. All right. And about x equals 7 pi over 4, we're going to say definitely in the domain. And that will be actually our only solution, as a matter of fact. And I have to do this. Okay. Just give me a second. Okay. So moving on to our next example. Our next example, example number 3, again similar to examples 1 and 2. So this time we have 10x minus 10, 1 equals 1 plus 10x, 10, 1. Again, probably recognize some pattern in here. So we have 10x minus 10, 1 in one side of the equation, and the other side is 1 plus 10x, 10, 1. All right. So what we are going to do is divide both sides of the equation by the right side, and we have 1 plus 10x, 10, 1. Okay, I'll make this bigger because it's a little tight in here. And then 1 plus 10x, 10, 1. All right, the formula that we suggest we use in here is 10 of a minus b equals 10a minus 10b over 1 plus 10a, 10b. All right, so back to our solution. The left side of the equation condenses to become 10 of x minus 1, and the right side is simply 1 because we are dividing an expression by itself. So x minus 1 is inverse 10, 1. Okay. And we're going to say x minus 1 will be pi over 4. And let's bring our angle or the diagram in here. And pi over 4 is right here. Okay. And the other angle with the same tan ratio will be found by extending this in the opposite quadrant. And there go our solutions. So one angle here and one here. So we have pi over 4. 1, 2, 3, 4, 5 pi over 4. Okay, so getting back here, we have to state our answers as x minus 1 equals pi over 4, x minus 1 equals 5 pi over 4. So x equals pi over 4 plus 1, or even better, pi plus 4 over 4, or x equals 5 pi over 4 plus 1, or 5 pi plus 4 over 4. So these two will be our exact answers. Sorry, I just want to make a small change in here. So the exact answers all right. But we can also find our approximate answers in here simply by using a calculator. By the way, I found this calculator online. It was free, and I am going to find the approximate value. So what we have in here is pi plus 4, so pi is under, so plus 4, and that's divided by 4. Please remember to use the brackets for the numerator, and that gives 1.79 radians, and the other one was 5 pi, okay, plus 4 divided by 4, so 1.79 and 4.93. So going back, we have the approximate answers now as 1.79 we said, and 4. What was it again? 4.93 radians. Okay, so these would be our approximate answers. Now, one thing to remember is that whenever we are rounding the answers, when the angle is expressed in radians, we must round to 2 decimal places. So I'm gonna make it clear here. Round to 2 decimals. Okay. When angles are in radians. Okay, so the next example brings a new story in. So we have 2 sine of x plus pi over 4 equals root 2 cosine of x. So 2 things that I want to emphasize here or bring to your attention in here. Number 1, now we have a variable represented by a sine in here and a cosine. Not a good news. And then when it comes to the angles, what we see we have in here is pi over 4 and x. Definitely not a good news either. So what are we going to do? So we're going to deal with this problem one at a time. So first we're going to make sure that our trig ratios will have just x inside it. So how do we do that? So first thing we want to do is expand this. It's compound angle formula. So we have 2 and then sine of x. Sorry about this. Sine x cos pi over 4 plus cos x sine pi over 4, and then that equals root 2 cos x. All right, and next step, what I see that what I have achieved in here is that inside for the angles I have for the angles at least I have x with a sign here, x in here, and x in here. So I'm happy with that. And next step is expand or bring 2 in. So what we have is 2 sine of x. And another thing we want to do is replace the cos pi over 4 by its respective value, numerical value. We know that pi over 4 is special angle, cos pi over 4 is root 2 over 2. So I will do that, root 2 over 2. Another thing that I want to do here is I would make sure that I bracket sine x and I bracket root 2 over 2. And that's because I don't want to confuse myself thinking, oh, x is multiplying root 2 over 2, so that's the angle. Because we all know it's not true. Okay, here we go. And then we have plus 2 cosine x. Sine pi over 4 is root 2 over 2. And again, in brackets, and that equals root 2 cos x. Okay, so I have sine x, I have cos x, I have cos x in here, and next thing I want to do is simplify a little bit more, if possible, and here I am simplifying. So number 2 will simplify, so the coefficient 2 will simplify the fraction, the denominator, and this one as well. Rewrite the equation. So we have root of 2 sine x. This would be plus root of 2 cos x equals root 2 cos x. So I kind of like that the equation looks a lot simpler, and you probably notice and are as excited as I am right now to cancel out root 2 cosine of x. You have the same term, exact same term on both sides of the equation. I am going to show the work though. I'm going to write root 2 sine x, bring all the terms to the left side, root 2 cos x minus root 2 cosine of x equals 0, or root 2 sine x equals 0. Okay, so you probably see here that these two will add to 0. All right, so here we go again. Divide both sides by root of 2 if you wish, why not? And we get sine x equals 0. All this work to discover this. Okay, and now we have to explore what angles will give sine of 0. So here is our diagram, and I am going to try to draw my angles. And the first one is the angle 0. Oops, why did this happen? It wasn't supposed to. Okay, so the first angle is the angle 0, has a sine of 0. Also, the angle 180 has a sine of 0. And here is 180. And not just this, but 360 or 2 pi will have a sine of 0. So going back to our solution, we're going to say, hey, x is inverse sine 0. So we just found out that x can be 0 radians, or x can be pi radians, or x can be 2 pi radians. So we got not just one, not just 2, but 3 solutions. So here goes the first one, the second one, and then there goes the third one. Oopsie. All right. So moving on to the next example, number 5. 2 sine 2x equals root of 3. Now, one thing I want to point out before we start is our domain. Remember that our domain was x between 0 and 2 pi. Now, when you look at this equation, you notice that you don't have just angle x in here, you have the angle 2x. So what that means is that we are going to solve for angle 2x first, and then we'll figure out what x equals. So, again, I will isolate sine of 2x first. Okay, this term. So sine 2x equals root 3 over 2. Okay, so that's kind of easy now. So angle 2x must equal inverse sine root 3 over 2. Now remember that if you are solving for angle 2x and x is between 0 and 2 pi, it means that the angle 2x will have double the domain of x. So double 0 is 0 and double 2 pi is 4 pi. So we are going to explore quite a few answers in here, or solutions. I'm going to draw my triangles again very quickly. Oh, it's not even a triangle. It's okay. You know what I mean. So we have 1 2 root 3, 1 root 2. So sine of root 3 over 2 suggests that we have the angle 60 degrees or pi over 3 here. So I'm going to start with my first answer. My starting angle would be pi over 3 or 60. So here I go. Okay, so the next angle with the same sine ratio will be this angle here. So these are the two arms or terminal arms I am going to need for now. And let me see, I want to make this green. So 1 and then 2 angles. I'm going to write these two first because they are the most important, or the more important angles, I should say. And I'm going to write 2x equals pi over 3. Or 2x equals, so remember 1 pi over 3, 2 pi over 3. Okay. Now the other angles are simply found by adding 2 pi to each angle that we just found. So we're going to say that 2x equals pi over 3 plus 2 pi. 2x equals 2 pi over 3 plus 2 pi. So we have formed quite a few equations now. So we have formed this equation, 2, 3, and 4 equations. So hopefully we're going to find 4 solutions. So I'm going to start solving. So from here we get x equals pi over 6. The next one, x equals, so divide both sides by 2 or multiply by a half. Same idea. So time by 1/2 in here. And then we get x equals 1 pi over 3. The next one, 2x, equals 1 pi over 3 plus 6 pi over 3, 7 pi over 3, which will make x equal to 7 pi over 6. And last but not least, we have 2x equals 2 pi over 3 plus 6 pi over 3, that's 8 pi over 3, which will make x equal to 4 pi over 3. Again, it's the same idea here, so you multiply by 1/2 both sides, and you can see how these will simplify to give a 4. Okay, so let's highlight our answers now. This is the fun part, I think. So we have one solution here for x, pi over 6. The next one, pi over 3. 7 pi over 6. Oopsie. And 4 pi over 3. So, interesting. Okay, so here we are. And now we are going to move on to the next example. Again, I would suggest that you try this example on your own. It's very similar to what we just did, but this time, instead of double angle, we have half an angle. So you may pause the video and try on your own. And again, just to refresh our memory, so the domain of our angle x is 0 to 2 pi. So therefore, we're going to say that a domain for 0.5x would be between 0 and half of 2 pi, which is pi. So let's get started again. divide both sides by 2, and that will give cosine of 0.5x equal to a half. So that will make 0.5x equal to inverse cos 1/2. And 0.5x would equal, so remember again, where is cosine equal to 1/2? We have our triangles in here, so 1/2 is the adjacent of our hypotenuse, pi over 3. So we're going to say pi over 3 is our angle here. You can also use a calculator, definitely. And I'm going to draw the angle pi over 3 now. I'm going to choose color red, pi over 3. And the next angle with the same cosine ratio will be in quadrant 4. And it will be from here to here. And there go our angles. So this would be angle pi over 3. And this is 1, 2, 3 pi over 3, 4 pi over 3, 5 pi over 3. So pi over 3 and 5 pi over 3. So back to our solution, we're going to say 0.5x equals, or can equal also 5 pi over 3. So divide both sides by 0.5 to get to our angle, or multiply by 2, and we get x equals 2 pi over 3, or x equals, so multiply by 10 pi over 3. So 2 pi over 3, so to have just to get an idea, so you have 2 pi over 3 will be in second quadrant. So quadrant 2, which means in our domain. So we will list this as a solution for x. And 10 pi over 3 would be actually greater than 2 pi. And you can look at it right here, actually, as a matter of fact, 5 pi over 3, right? It's more than a pi. So and 0.5x has to be less than or equal to pi. So we're going to say that this is an extraneous solution. But we do have an answer right here, so that's the solution to our equation. So moving on, more examples. So solve the following three equation as a linear equation. Okay. So again, try this on your own. I'm pretty sure you can recognize the patterns here very easily. And I'm gonna start solving it with you. 2 sine x cos x equals cos 2x. So you probably recognize that the left side of this equation represents one of the very important formulas in trigonometry, and it equals sine of 2x. So you can rewrite this equation as sine 2x equals cos 2x. Again, we want to have a single variable in our equation, so to do this, we're going to divide both sides by cos 2x. And that will give us tan 2x equals 1. Now again, remember the domain is between 0 and 2 pi for x. So that means for 2x, double x would be 0 and 4 pi. So when we solve, we have to solve for, we have to search for answers throughout 0 2 pi. Okay. Okay, so we're going to say that 2x equals inverse 10, 1. So 2x equals pi over 4. So, and I'm going to draw this angle here. So here goes pi over 4. The other angle with the same tan ratio would be across from it. And here we get the first angle and the second angle. So we get pi over 4. And we get 1, 2, 3, 1, 2, 3, 4, 5 pi over 4. So we'll write the answers here. 2x equals pi over 4. 2x equals 5 pi over 4. And to find the additional angles for 2x, we just add a 2 pi to each solution we just found. So 2x equals pi over 4 plus 2 pi, or 5 pi over 4 plus 2 pi. So all we have to do now is solve for x in each equation. So it seems that right now we have a handful of solutions. So one here, and then a second, a third, and a fourth. So we need to solve for x. Okay, so back to our answer. So we have x equals pi over 8. Or x equals 5 pi over 8. Now, here we have to do a little bit more work. Pi over 4 plus 8 pi over 4, that's 9 pi over 4. So that will leave us with 9 pi over 8. So it's still close to pi. And same idea here, 2x equals 5 pi over 4 pi, 8 pi over 4, that's 13 pi over 4. So x equals 13 pi over 8. So let's take a look at all our answers. So we have x equals pi over 8, x equals 5 pi over 8, 9 pi over 8, and 13 pi over 8. Beautiful, isn't it? So 4 solutions for this equation. Okay, moving on to another question. So in this case, we have tan 3x minus 10x equals root 3, 1 plus tan 3x, 10x. It's a combination of the types of equations that we have seen already. You probably recognize in here the compound angle formula for tan. So I'm just going to write it down here one more time. So that's tan of a minus b, right, which is tan a minus b 1 plus tan a tan b. Okay, so you can see here that here we have the angle 3x and x, and 3x and x. So that's how we come up with the idea of using this formula. Okay, here we go. So we're going to divide both sides of the equation by one plus tan 3x, tan x. Okay, so we have, let me make this a bit bigger, tan 3x minus 10x over 1 plus tan 3x, 10x equals root 3. So this would be tan of 3x minus x equals root 3. So that's tan 2x equals root 3. That's the most simplified form of the equation, the most simplified form we can bring the equation in. So here we go. And what we're going to do is solve for 2x. So the same drill. We have to refer to our domain first. Our domain was between 0 and 2 pi. So for the angle 2x, will be between 0 and 4 pi. So I'm going to draw the triangles in here because I know in special triangles we have some root of 3. I don't know what's going to happen though. So here we go, the first special triangle and the second special triangle. Okay, not much of a triangle, but I'm going to try one more time. Okay, better. And 1, 2, root 3. Okay. And 1 root 2. So root 3, so the 10 with root of 3 would be this one here, root 3 divided by 1. So it looks like we have a special angle here. And the special angle is pi over 3. So we're going to go ahead and draw the angle pi over 3 again, or 60 degrees. And here we go. I actually meant to do this. Okay, that's a little better. Not really. Sorry about that. Oops. Okay. And the next angle would be the one that defined by 1, 2, 3. Okay. So there go our two angles. So pi over 3, 1, 2, 3, 4 pi over 3. Okay. Okay, so we're going to list our solutions. So we're going to say 2x equals inverse tan root of 3. So 2x equals pi over 6. Or 2x equals, pi over 3 we said, right? Two x equals 4 pi over 3. To find the additional angles to within 4 pi, we just added 2 pi. So 2x equals pi over 3 plus 2 pi. Or 2x equals 4 pi over 3 plus 2 pi again. So what we are going to do now is, okay, so solve for x in each equation. And that will give us eventually all the answers. Okay, so x equals pi over 6. X equals 2 pi over 3. Remember, so what we do in here is multiply by half both sides, right? Now the next one will give pi over 3 plus 2 pi is 6 pi over 3 plus pi over 3, so 7 pi over 3. So x equals 7 pi over 6. And last but not least, 2x equals 10 pi over 3. Or x equals 5 pi over 3. Okay, simplify or multiply by 1/2 here. Okay. Alrighty then. So let's take another look at our solutions here. Make them green this time. So we have x equals pi over 6. X equals 2 pi over 3. 7 pi over 6. And 5 pi over 3. All right. Oh, 10 examples. So 2 more examples. So that's a good practice. 6 sine 5x cos 3x equals 3, 6 cos 5x sine 3x. So you probably noticed that we have an alternation of the angles 5x and 3x repeating in 2 terms. And we have 5x right here, and 5x here, and 3x in here, and 3x in there. So that's some good news. What we're going to do is we're going to bring these 2 terms closer to each other so that we can have an idea what to do with them, or what to do about them. So here we go again. 6 sine 5x cos 3x. When you think about it, actually what we are doing is something that we have normally done when we solve linear equations. So take the variables in one side, keep the constant in the right side or in the other side, whichever side you use. 5x sine 3x equals 3. So we can factor out 6. It looks like we have a common factor in here of 6. So I'm going to take that out. So sine 5x cos 3x minus cos 5x sine 3x equals 3. So still 6. We're going to actually combine all these together into one term. So what we have in here is compound angle for sine, for the difference of the angles. So sine of 5x minus 3x. So 6 sine 2x equals 3. Sine 2x equals half, 3 over 6. So again, we're going to talk about our domain, which was for x between 0 and 2 pi. And now we are going to reconsider it because we want to find the angle 2x here, which will expand the domain to 0 and 4 pi. So that's the domain that we are going to look at. Okay, so same drill as in the previous questions. So we're going to have 2x equals inverse sine 1/2. That's a special angle of pi over 6, yes. So we're going to say pi over 6, where are you? Right here. The next angle with the same sine ratio will be the reflection of the terminal arm about the y-axis. So here we go. And that's all we need actually, only 2 terminal arms. The rest we can figure out. Slowly here. I'm going to pick a different color to indicate the angle. So here we have pi over 6. And let's see how many pi's over 6 we have. Pi over 6s we have here. 1, 2, 3 pi over 6, 4 pi over 6, 5 pi over 6. So I think I'm ready to write my answers now. So 2x equals pi over 6 or 5 pi over 6. Since we have expanded the domain, so since we've doubled the domain, we're going to say, well, add 2 pi to pi over 6, and you got a third solution, and add 2 pi to 5 pi over 6, and you got all the solutions. So here are all our solutions so far, still unsimplified. And we're going to solve for x in each and every one. So x equals pi over 12. So remember, you're multiplying by 1/2, right? Here. You multiply by 1/2. You multiply by 1/2. Not yet here, actually. and we get x equals 5 pi over 12. Here we have to do a little bit more work before we isolate x completely. So pi over 6 plus 2 pi is 12 pi over 6, 13 pi over 6. So that will give x of 13 pi over 12. And this one would be 2x equals 5 pi over 6 plus 12 pi over 6, 17 pi over 6. So that will give x equal to 17 pi over 12. All right, so let's take a look at our answers now. So quite a few of them. One solution. Here goes the second, the third solution, and last but not least, 4 of them. Here go all 4 of them, smiling at us. All right, so moving on to the very last example for today. Okay, so cotangent x cosine x equals cosine x. That's completely different than the questions that we have, or equations we solved so far. Thank you so much for following me, actually. I guess it's been a very, very long lesson. Well, as always. And we are going to solve the equation cotangent x cos x equals cosine of x. So, as you can see in here, we have cos x, not a problem. But then we have another variable, cotan of x. So we have to find a way of simplifying that. And probably some of you are thinking, oh, maybe if I replace cotan x by cos over sine, something is going to happen. If you're one of those people, then I will actually satisfy your imagination by doing this question that way. So if you were thinking of substituting cotan by cos over sine, and you multiply by cos, we don't really, or we're still unable to simplify cosine. So maybe that won't be a very good idea. But whatever ideas we have, it's always good to try. Because when we understand why something doesn't work, we have learned, or we are kind of paving the way to thinking of how and why, or what can work, okay? So we are directing or redirecting our thinking. So anyhow, so in this case, what we are going to do is we're going to take cosine x to the left side. So why would you do that? Well, it is true that you don't have same variables throughout the equation. But here we have actually 2 terms multiplied together, both variables. And the other side has just cosine of x. So they do have a common factor, as you can see. So let's bring them over to the left side, bring all the variables to the left side, and leave just numbers to the right side. It's a linear equation at the end. So cotan x, cos x, minus cosine x equals nothing. And since we have cosine x, a common variable, right? So we are going to take out cos x, and in brackets we are left with cotan x. Why did I do that? All right. Cotan x minus 1 equals 0. So we have 2 factors here, cosine x and cotan x minus 1 that multiply to 0. So guess what we're doing then? We're making each factor equal to 0. Now, can we solve these equations? So we're going to have x equals inverse cos 0. And according to this equation here, x equals inverse cotan 1. All right, so let's get to work. 0 would be the cosine of the angle. Let's look at, you can use a calculator anytime, right? I always like to use my diagram because it kind of integrates my thinking with my imagination. In the meantime, I want to also see how the numbers work and how they fit into each other. So 0 would be the cosine of the angle 90, because that's where the coordinate x is 0, right, for the angle, and also angle 270. So I'm going to say, well, from this equation, I get x equal to 90, or pi over 2. We have to speak the same language as the domain, or x equals 3 pi over 2. Now for cotan, we have a slightly different story. So cotan equals 1 for angle pi over 4. Now, when the ratio is 1, doesn't matter if you're using tan or cotan, just in case you were thinking of converting cotan into tan. So it's not as complicated. And we're going to look at the angle pi over 4. I'm going to pick a different color here just because we're looking at a different equation. So that's one angle. And the other angle is found by just extending this. Let me see, I'm going in the right direction here. I'm definitely going in the right direction. Okay, so here we go. That's 1 pi over 4. I shouldn't have done that. Over 4. And then 1, 2, 3, 4, 5 pi over 4. So that will be this angle here. So let's state our solutions. We have pi over 2, we have pi over 4, and 5 pi over 4. Okay, so 4 beautiful solutions. And here we go again. Pi over 2, pi over 4. That was not supposed to happen again. And then next one is 3 pi over 2, and last but not least 5 pi over 4. Thank you so much for watching. Have fun practicing the rest of the questions assigned, and I will hear from you soon. Bye for now.